welcome back to the bioenergy lecture series. So, we concluded the last class with the gasification techniques. Today we will talk about the history of the gasification in terms of the vehicle fuels. You might wonder that today we are teaching this subject, but it will surprise you. The gasifier based vehicles have been running since the time of Second World War, even earlier than that. As a matter of fact, gasifier system was widely developed in Sweden, where at one point during very early 1900, there was a lack of petroleum products, petroleum supply, and they invested heavily on gasifier system. And they use the flatbed gasifiers. We'll note down all these things for your convenience. And after this, during Second World War, there was a shortage of fuels. And the technology which was developed in Sweden and few other places in Europe came very handy. So there were vehicles which were driven using gasifier reactor systems. Okay. So what we will do today, we will just briefly enumerate the little bit of the history, and then we will talk about the challenges and where the technology kind of lost and again getting revived in the present time. Okay, to start off with, so we will talk about the vehicle fuel using gasifier, vehicle fuel using gasifiers. Okay. So, the use of gasification to provide a fuel for motor vehicle for biomass is very well proven and documented. Okay. Well, this is very time tested technology, well proven and documented, very well documented. The last 100 years of literature has several such documentation. And it all started during 1920s in Sweden. This is post World War I, okay, where the technology was really picking up, followed by 1939 to 1945, this is World War II. This was the time there were shortage of petroleum products in Europe and led to the need to develop alternate technologies to provide fuel for motor vehicles. So, if you look at in 1920s, we are almost approaching 2020 now. Okay. So, this technology is very much there, but what happened post World War is, I will just put it in red, post World War you are getting lot of improved fuels, and due to the improved fuels this technology somewhere get lost. People post Second World War, there was not much investment happen in this technology, because you are getting very high quality, very refined oil for different kind of aviation purpose, different transportation. So, this technology kind of took a back seat. But today let us revisit some of the pros and cons of this technology. So, let us jot down the salient points. The salient points of this technology are, so there is this wood gas technology, there is hardly any bottleneck, there is no bottleneck, we know this technology. It leads to low calorific value wood gas, and it requires, what are the requirements to drive vehicle for this? Requires high compression ratio. You remember when we had talked about the compression ratio while talking about the engines, high compression ratio to provide the same engine performance, to provide the same engine performance okay, necessitating the need for strong built engines. Mostly they are very similar to the diesel engines. What could be used? So, mostly the diesel engines come very handy for this kind of situation. Okay. Whereas, second aspect is that engines with large cylinder volumes, engines with very large cylinder volume, larger valve area, okay, operating at constant load, operating at constant load at low RPM, at low RPM gives optimum power output, optimum power output. Okay. This is very important. So, it is basically stationary industrial engines. And secondly, the small high speed engines like 4-stroke engines are not very successful in this kind of setup. 4-stroke engines are not very successful, they are not very efficient in this kind of situation, whereas the 2-stroke engines are very successful for this kind of wood gas system. 2 strokes are fairly successful. Okay. And if you look at how these are being made, so I will give you a flow chart of it, gasification to produce fuel from the gas for the gas engines. So, flow chart will kind of give you an idea, something like this, where you have, so this is your reactor vessel, a reactor vessel. Okay. So, you have the wood chip hoopers which are present here, and you have the air inlet. This is the hearth area. And here you have the blast tube. So, this is what you can put in the front of a car, right? And this is where you are having cyclone sitting here. From here it goes to the cooler area or the coolant, where you are cooling down the gas, and from here you move to the purifier zone, and here you have the gas air mixture conversion. So, in order to understand this, you recollect how we did this goes to the gas engine, and here you have the exhaust gas, and you have hot water. So, if you look at it very carefully, so this is where you have the reaction happening, this is where the gas is getting generated, and this is where you are running the engine. So, in one unit, so you can have the front of the car, say for example, this is your car. So, you could have this whole setup out here, this is what you see out here, and there are cars which are developed in that whole process where you have the whole setup in the front and you run the car using these kind of gasifiers. But the challenge is that you will get a low calorific value fuel. Obviously, the power of the engine will be less, and as I have mentioned earlier, these can only run the two-stroke engines. So, automatically you will have to compromise on the speed and the efficiency of the system. And on top of that, what all we have discussed, there will be charring problems, there will be ash problem, and if you look at this point very carefully, there will be water which will be coming out, it will be utilizing the water which will be have a lot of contaminants. So, you have to purify this water, and of course, you have the exhaust gas coming through. So, overall this is how this whole technology of 100 years functions, and there are different ways you can do it. So, this is one technique where you are doing the thermal A. The other way of what I was mentioning of gasification is the biological route of gasification. So, in terms of the very briefly I will touch upon that biological route of gasification. In the biological route, instead of using high temperature, what you are doing, you utilize two technologies, the fermentation technology, this is one route. The other route what you use, which is basically follows anaerobic digestion. What we meant by anaerobic digestion is essentially there are series of bacteria, microbes, fungi, which in the absence of oxygen, as I could see, there are microbes which works on biomass, on top of biomass. Here if you have the biomass, and they generate a lot of gas, especially bacteria like you have such microbes like methanogenic microbes which produces methane and all these kind of things. So, this is another route by virtue of which you can think of generating a lot of gas. So, in the beginning of gasification I told you, one is the thermochemical route, what we have extensively talked about, and we talked about a little bit of the biogas plants earlier. So, most of these techniques, the whole idea is very simple. You have a biomass which has to be degraded, and you could have liquid based fuel or you could have solid fuel or you could have gaseous fuel. Okay. So, in terms of the gaseous fuel, you could either follow the microbial digestion route or thermochemical route depending on your economy and how you want to recover the system. The thermochemical route is very well established. Microbial route we know, but really to scaling up is the current area of research which is going on. So, this brings us to almost at the fag end, where let us look through what all we discussed. So, we started our journey with, first we talked about the energy status and the context of bioenergy. Okay. We talked about in the very early part, if you remember, energy status, followed by we talked about the photosynthesis, and we talked very extensively about photosynthesis because this is the route which leads to the formation of biomass. This is where all the carbon dioxide is coming and through green machinery is converting into biomass. This was one area we invested or investigated very, very profoundly, the biomass formation. Okay. Next, what we talked about is the different conversion process, which is the technology part. Conversion of biomass to solid, liquid and gaseous fuels. And by no count that this course is fully complete, because there are whatsoever you try, there will be certain parts which will be missed. But what is important is that where I have put the maximum thrust is this two aspects. One is this aspect where I invested a lot of time for you people to appreciate that this is critical. Once one has to understand that why we needed to increase the photosynthetic efficiency of the plants which are growing on earth, and the second part, the overall the conversion technologies which are at our disposal. Then this leads to the next part where we talked about the different kind of biofuels, which partly we discuss here and there all over the conversion process, biofuels and bioenergy. Okay. And of course, we have talked about the solid, liquid and gaseous fuels, and they are where they are applied in terms of automobile, which transport, electricity generation, likewise, and so on and so forth. And all these processes, if you realize, leads to emission of CO2, and this very same CO2 again comes back to feed this cycle. So, you are realizing it is a continuous process which is happening. So, based on this energy status, we moved on to the whole area of bioenergy with a specific stress on bioenergy. Then we moved on to the basic process, the photosynthesis, to the biomass conversion, then again the conversion of the biomass to solid, liquid and gaseous fuel. Here I have highlighted time and again that nature has also done this process through natural geological era. In that process, nature has already formed natural gases, petroleum and coal. These are nature's analog. What we are trying to do is that now man wants to do this whole conversion in his lifetime, which is essentially. So, this whole process must have taken nature some billions of years, where through geological eras it has converted most of the biomass at high pressure and high temperature to different kind of fuels. Now, man wants to understand all those things and wants to do the same thing in a synthetic condition. So, this whole conversion process what we are talking about by man is through a synthetic route or synthetic microbial, whichever you call it, synthetic man controlled route. It is not that nature has not done it, but when we do this, so that is why I was highlighting that this has brought us to a very different time in civilization, where human being by sheer ingenuity dared to do nature the way nature has done it. So, it is a very important time for us to appreciate this area, which is very tough. It is not something very easy, and it is not that little bit investment here and there is going to make a huge. It will be a journey of young people coming into this area of research, investing their life. Probably another 50 or 100 years of research is needed before we can even understand some of these different geological processes which lead to the conversion of biomass to natural gas sources, to petroleum, to coal, and we wanted to do that now in the lab. That is no joke. That is a very daring dream for mankind. So, that is where I highlighted that this whole area of synthetic man control route, understanding the chemistry behind it, understanding the physics behind it and designing the reactors and everything in order to utilize them is kind of exceptionally challenging. And this brings us to a concept what I was trying to mention, what we really understand by biorefinery, because it is a very open concept. So, it is essentially, it will be something like this. from different sources. Say for example, you have plant sources coming from water bodies, okay, water and land, all the plant sources, plant or all other sources what we have talked about, the biomass sources, they come to one platform which is kind of a refinery where all are converted to different kind of product, say solid fuel in terms of the fuel product, solid, liquid and gaseous fuel, and then distributing them for different kind of application, and what all exhaust what we are getting is again fed to some way into the nature in order to convert it into biomass. So, this whole concept is what will be the modern day biorefinery, where most of the biomass to fuel conversion process in a very systematic man-made controlled fashion, where this is going to happen. Okay. So, here I will highlight few additional aspects. There will be at the end, there will be two small capsule of videos where I promised you I will show you how the pyrolysis process could be used to make graphene like material where electricity production takes place and how to store it. And there is another aspect which I have added there, where you can use natural fibers. So, we talk about these biomass sources. These natural fibers could act like thermoelectric materials, where if you take a natural fiber and expose it to waste heat, it could generate sufficient electricity which could be stored. So, it is a very preliminary research, but I have just gave you a glimpse of another area of thermoelectrics and energy storage materials which could be derivatized from different biomass kind of biomass. Okay. So, thermoelectrics, and I haven't, this is not part of like kind of, it will be too exhaustive for the course, but just I have given you some video modules which will help you to appreciate it, and you will have energy storage materials, energy storage. Okay. These are the different kind of materials what we have talked about in the video module. So, that pretty much brings us to the end of the course, where we have started from the energy status. We talked about photosynthesis, we talked about the photosynthesis to biomass conversion, and then we talk about the conversion technologies available to us. We talked about the design of the engines, and then finally, we sum total the whole thing and we talked about what is the future. So, it was definitely a great learning experience for me, and I hope it has helped you to get an overall picture of bioenergy, and wish you all the best, and keep posting your questions in the forum. As long as it is active, we will answer it, otherwise you will have my email ID. So, many of you emailed me, I could not really respond back during the course because of a very busy schedule. Please feel free to contact me over the email, and the TA who is answering, who is also available, and all the best and do well. Thank you.